Let's talk about Pascal's triangle. Have you ever seen a problem that has the quantity of x plus 4 raised to the third power or something to that effect, and then you thought, well, how would I do this? Most people would try to expand that out because that simply means to take the quantity of x plus 4 and multiply it times itself this many times. So if this number were to change to 5, then I would add 2 more sets of parentheses. But there is actually an easier way to do this. So in doing this, what I'm going to do is set up my Pascal's triangle. So let's see how that works. It looks like a triangle. So the beginning and the end start with the 1, and so does the top. This first row is actually your 0 row. This is your first row. Second row, third, fourth, and fifth. So you just have to remember you always use 0 when you're counting with the Pascal's triangle. And the way you set it up is you add the two numbers that are above. So 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 1 is 3. 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. And then you continue doing it. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. And 4 plus 1 is 5. If you're ever confused about which row is which, just look at the number that is associated with it. So in the middle here, you see the number 2. So on the outside, I know it's number 2. Most people will want to start with number 1. You're going to throw your numbers off if you do that, because again, there's a pattern. If you can 1, 2, 3, 4, 5, you see that? 1, 2, 3, 4, 5. So just make sure you're following your pattern. So let's use this with one of our problems. So what I did is I went ahead and color coded because I'm going to show you a way that I prefer, but the first thing I'm going to show you is a way that most people will teach it. And what they will do is they will take those coefficients that are associated with this particular exponent. So let's go back to the Pascal's triangle. So I'm looking for row 5, which is the one that has the 5 at the beginning and the end. So it's always whatever is shown as your exponent. And what they will tell you to do is to take those coefficients, because that's what the Pascal's triangle numbers are representing, your coefficients, and place them with spaces in between. Since there's a plus sign here, I'm going to put a plus sign for each of my coefficients and try to leave some space because you're going to have to fill something in between. I don't like this method because it gets really crowded. You'll see what I mean here in a minute. So then what they will do is they will tell you to take your first term, which is x, take the power that is raised to 5, and then count down. X to the fourth, x to the third power, x squared, x to the first power, and remember how I said you have to use the 0? X to the 0 power. Side note, anything raised to the 0 power is 1. So this is just going to turn into 1 anyway. Next thing you want to do is you want to look at your second term, which is the 3. But this time you want to go in the opposite direction. So really, there is going to be a 3 to the 0 power. And a few minutes ago, I just told you anything to the 0 power is just 1. So as to not confuse yourself, go ahead and get rid of that. And then 3 to the first power, 3 to the second power, 3 to the third power, 3 to the fourth power, and then see how crowded it's getting? Again, I personally don't like this method, but I just want to show it to you just to see, so you'll know somebody might like this method, so you might want to use it. So then once you simplify everything, you have x to the fifth plus 3 to the first power is 3 times 5, 15x to the fourth power, plus 3 squared is 9, 9 times 10 is 90, x to the third power, plus 3 to the third power is 27, 27 times 10 is 270, x squared, plus 3 to the fourth power is 81, 81 times 5 is 405, bring down that x, it's just 1x, and then 3 to the fifth power is 243 times 1 is still 343. I'm sorry, 243. I said 300. 243. And this is your answer. You know that you're doing it right because your, say for instance, your x variables will count down from this number. 5, 4, 3, 2, 1, and then there's not 1. So that's the way that most people teach it. The way I would actually suggest is set up a table. So if I'm setting up a table, I'm still using those coefficients. I'm going to use 1, 5, 10, 10, 5, and then 1. Leave some space because you're going to have to write in between. So for the first one, I do the same thing that was suggested here, x to the 5th power, and then I count down. But this time, since there's just an x, I take this number and go ahead and bring it down. So I would have 5 x to the 4th power, 10 x to the 3rd power, 10 x squared, 5 to the x power, and then x to the 0 power, which is really 1. And 1 times 1 is still 1. Anytime I see that 0, I get rid of it because I don't want to be confused by it later. The next thing I do is I take my second term, which is 3, and this time I don't start with 5. I do the opposite. I start with 0. So 3 to the 0 power is really 1, so I'm going to go ahead and get rid of that. And then I have 3 to the 1st power, which is 3. Once I simplify it, I get rid of it so I don't get confused. 3 to the 2nd power, 9. 3 to the 3rd power, 27. 3 to the 4th power, 81. And then 3 to the 5th power, 243. So what I am doing now is I am going to not only simplify, but I am simplifying, but this time I'm going downward. So I'm going to take this information and whatever I have, I'm going to multiply it. So x to the 5th times 1 is simply x to the 5th. Hold on, so you can see it's going to be the same answer. 5 times 3 is 15. Remember, this is a plus sign, so 15, and then bring down that variable, x to the 4th. 10 times 9 is 90, x to the 3rd. 10 times 27 is 270, and then bring down that variable. 81 times 5 is 405x. And then finally, the 1 times 243 is 243. Again, I already told you it's the same answer, 5, 4, 3, 2, 1. Okay. Now this next one, it actually has it has a coefficient and a variable. So you want to make sure you put that information inside of a parentheses. But first, looking at our exponent, which is 3. Okay, didn't want to work for me. There we go. Which is 3. Let's go up to our Pascal's triangle and look for row 3. So we know our coefficients are going to be 1, 3, 3, and 1. So that's what we're going to write in our table. 1, 3, 3, 1. The first row is going to start with the first term, but again, make sure you're putting it in parentheses. And you always take your first term and raise it to this power, and then you start counting down. So I'm going to take this number and bring it here, but next to it, I'm going to write that 3x, and I'm going to count down 2. Take this number and write the 3x, and this time it's to the first power, and then again take the 3x. Yeah, there's not a 3 this time, there's just a 1. So 3x is raised to the 0 power. Anything raised to the 0 power is simply 1. So 1 times 1 is still 1. So that's that part. Now I go to the second term, which is a positive 2. So 2 to the 0 power this time. Notice when you're setting up the table, these will let's go back to the other one so you can see it. The exponents will add up to what you started with. So my exponent here is 5. In my table, 5 plus 0 is 5, 4 plus 1 is 5, 3 plus 2 is 5, 2 plus 3, 1 plus 4, 0 plus 5. That's how you know you're setting your table up correctly. So let's do the same thing here. 3 plus 0 is that 3. So now I take this number 2 and I raise it to the first power, and I don't forget over here that that's going to be 1. So 2 to the first power. If you need to just go ahead and write this first and then go back and simplify, do that. 2 plus 1, 3. 1 plus 2, 3. 0 plus 3 is 3. Now I can simplify. This becomes 2. 2 squared is 2 times 2, which is 4. And 2 to the third power is 8. Now, if I am going multiplying down, my answer will be 3. Now, everything is in parentheses. That's why I said don't forget that. 3 to the third power is 27. So 27 times 1 is 27, and then x to the third power. The first term will always have this exponent. So x to the third power. And now 3 to the second power is 9. 9 times 3 is 27. 27 times 2, and this is a plus sign, so it's going to be a plus here, is 54 x squared. 3 to the first power is 3, times 3 is 9, 9 times 4 is 36. X to the first power is simply x, and then finally 1 times 8. If I'm checking to make sure I'm on the right path, x cubed, x squared, x to the first power, no x's. That's my final answer for that one. And then finally, if I look at this particular problem, now my exponent is 4. So let's go back to the Pascal's triangle, and we're looking at row 4 this time, and we will see that it's going to be 1, 4, 6, 4, 1. Those are going to be the coefficients that are in my answer. Okay, let's get this scrolling on up here. All right, so I'm going to set up my table with those coefficients. Again, it's 1, 4, 6, 4, and 1. And like I said, try to leave some space so that in between those numbers, so you'll have some space to write. First term goes first, and it's raised to that exponent, and then you just count down. Take this number, 4x cubed, 6x squared, 4x, and then x to the 0 power, which is 1, and 1 times 1. All right, so again, first term, and then you're counting down x to the fourth, x cubed, x squared, x to the first, x to the 0. Take this number, bring it out in front. That's your coefficient. Now you go to the next term. It has a negative. You have to keep up with that sign. So you're going to have a negative 2y to the fourth. I'm sorry, not to the fourth, to the 0 power, because again, they won't be the same. 4 plus 0 is 4. And this is really 1. Anything to the 0 power is just 1. All right, so the next one will be negative 2y to the first, which is negative 2y. Then you have negative 2y squared, which is really 4y squared. Negative 2 squared, which is 4y squared. And then you have negative 2y to the third power. Again, these are counting down. The ones on the bottom are counting up, 0, 1, 2, 3. And then you simplify. Everything in the parentheses has to be raised to this power. So negative 2 to the third power is a negative 8 and y cubed. If you have an odd number and you have a negative inside, the negative will follow. If you have a negative inside and you have an even number, a negative times a negative is going to be positive. So you will see a pattern when you have a negative number. It's going to be negative, positive, negative, positive. The signs will alternate. That's when that middle sign is a negative. All right, and then lastly, you have, negative 2y to the fourth power, which when simplified is negative 2 to the fourth power, which is a positive 16 because that's even, y to the fourth. Now doing your math going downward, x to the fourth times 1 is simply x to the fourth, and 4 times negative 2 is negative 8. This time, take this x cubed, put that first, and then that y, plus 6 times 4. And this is why I was saying, once you simplify, because it'll start getting messy, go ahead and get that out the way so you won't get confused by it. 6 times 4 is going to be positive 24, but don't forget the x squared comes first, then the y squared. And now you have 4 times negative 8, negative 32, x, y cubed, plus 1 times 16, which is 16, y to the fourth. With my x's, I'm counting down 4, 3, 2, 1, no x's. And then with my y's, I'm counting backwards, y to the fourth, y to the third, y squared, y to the first, no y. If I am adding my exponents, I see I have a 4, which is what I started with, 4. And then I have a 3 and a 1. 3 plus 1 is 4. 2 plus 2 is 4. 1 plus 3 is 4. And then finally just 4 by itself. So that is how you do Pascal's triangle if you are using the table method. So please like and subscribe. I truly appreciate. Thank you.